So now we will discuss the position of second dark fringe, okay, or the second minimum. So I told you that in the second minimum case, the path difference between this one and this one will be 2 lambda. Suppose I am giving one name here, P. This point is, suppose it is P2. This point is P2, suppose, okay, for the second. Now the path difference between AP2 and BP2 is 2 lambda. So if I just divide the slit taking another wave from C point in such a way that AC equals to BC, then angle between, I mean the path difference between AP2 and CP2 will be how much then? Half of 2 lambda means how much? Lambda. Lambda is the path difference between AP2 and CP2. Now can we do one thing? Can we again divide this part and this part into equal half? This one, if we divide, suppose this point I am giving a name D and this new point is suppose E, okay, then what will be the path difference between AP2 and DP2? Path difference between AP2 and CP2 was lambda. Path difference between AP2 and DP2 is lambda by 2, again half. Can you follow what I am trying to say is, it's like this, right? Screen, this point, path difference 2 lambda. This is A, this is B. From here C, this is C. Path difference, this is P2, no? So path difference between AP2 and CP2 is lambda. Again I am dividing this. This is D, this is E. So from D also one wave will reach, E also one wave will reach. So what is the path difference between AP2 and DP2? Lambda by 2. So if it is lambda by 2, now forget about this part. This part I am not talking about. I am talking about A, D and C point. The angle between, the path difference between AP2 and CP2 is lambda. Path difference between AP2 and DP2 is lambda by 2. So if it is lambda by 2, AP2 and DP2, if from AP2 the crest is reaching to P2, then from DP2 the trough will reach, because the path difference is lambda by 2, and if it is so, the intensity will be 0, means a dark one. Similarly, just below A, we have one point, just below D we have one point. From these 2 points also, whatever wave is reaching to P2, their path difference will also be lambda by 2. That means if the crest is reaching from one wave, the trough will reach from the other wave. So ultimately for this part in P2 we are getting a dark one. Similarly, in the same concept can be applied in this region also. Okay, fine. So ultimately point P2 will be a dark one. Under which condition? If the path difference between the extreme 2 wave is 2 lambda. In the same way, the third minimum or the third dark will be observed if the path difference between the extreme 2 is 3 lambda, 4 lambda, in that way it goes on. So here I have written 2 lambda is the path difference, just like the previous one. Okay, in previous one what you had written, A sine theta 1, because that was the first order. Theta 2 I have written here for the second order, and this is 2 lambda. Second order means second dark. Then same concept, these are same, I mean since the angle is very small, sin theta 1 was replaced by theta 1, so here sin theta 2 will be replaced by theta 2. Theta 2 is this one. Again same way, this is called what? Just like this, angular position of the second minimum or dark. So if angular position is obtained, the linear position can be obtained by multiplying only capital D. So capital D. Okay, in the same way for the nth dark, for the first dark, here we got 1, no, lambda D, and before that nothing is there, means it is 1. Second dark we got 2 lambda D. Third dark we will get 3 lambda D. For nth dark we will get n lambda D by A. Okay, fine. So this is the linear position, this is the angular position. So about dark we got. Now the question is that what about bright? Okay, so for bright, after central bright, the first bright is found when the path difference between the extreme two wave is 3 lambda by 2. Why it is so? Let us see this one here. Suppose this is point P. What happened is the path difference between AP and BP is 3 lambda by 2. This one. 3 lambda by 2. That means 3 into lambda by 2. Now if we divide the slit into 3 parts, this part and this part means AC, CD and DB, then path difference between AP and CP will be how much? Lambda by 2, because 3 lambda by 2 is the total path difference, means A and B. Okay, then path difference, and we have divided it into 3 parts, so means in each part how much should be the path difference? Lambda by 2. Okay, so path difference between AP and CP is lambda by 2. So due to that, at point P there will be dark, because if one crest is reaching, the one trough will reach from C. Similarly, just below one point A, another wave will reach to P. Just below C, also one point we have. So from there also the wave which is reaching to P, they will also have a path difference lambda by 2. So both will cancel each other and the intensity will be 0, means dark. This thing will continue up to point D only, no? After point D, for this region there is no pair region from which we are getting waves having path difference lambda by 2. For AC region, whatever wave we have in AC region, all the waves has its pair in the DC region having a path difference lambda by 2. That is why they are forming a dark image here, dark point here. But what about DB? It does not have any pair, because AC it has already cancelled with CD. Only one is left now, that is DB region. So whatever wave is coming out from DB region, that is meeting to point P, and it has no pair which can cancel its intensity. So ultimately, due to this region, DB region, at point P we are getting some intensity. So point P will be a bright one in this case. Can you follow? Bright one. Okay, the reason is that because it is 3 lambda by 2, 3 is a even odd number, so that is why we divided the slit into 3 parts. First 2 parts will cancel each other, but the third part will contribute to the intensity. Same way, if I say 5 lambda by 2 is the path difference between the extreme two, then this whole slit AB should be divided into 5 equal parts. 5 equal part means first 4 part will cancel their intensity, because that is even. They will have a pair of one another, right? What about the fifth part? The fifth part will contribute to the intensity. That means for this path difference also at point P we are getting a bright one, second bright. Okay, so for 3 lambda by 2 bright, 5 lambda by 2 bright, 7 lambda by 2 bright, in this way it will go on, and the general expression will be twice n plus 1 lambda by 2. Okay, that's what we have written here. The process is same. Delta x is 3 lambda by 2 for the first bright. Again delta x means what? A sin theta 1. Theta 1 I have written because it is first bright. 3 lambda by 2. Similarly theta 1 is this one, just like this. Okay, just like this. Then y1 will be what? With this we have to multiply a capital D to get the linear position. This is the angular position. Second bright, as I told you, 3 lambda by 2, this will be 5 lambda by 2. So from this theta 2 is this, y2 is this. Okay, then general formula. For general formula, what we should do? Instead of writing 3, 5, 7, finally for nth order we will write twice n plus 1 lambda by 2a. 2a was there only. Okay, this is for angular one, and for linear one here we have to multiply capital D like this. So this is the linear one. Okay, for bright, this is for bright, this is for bright. For dark, the general expression is this two. Okay, then in the next video we'll find out the fringe width. Fringe width. Okay, one very important thing that I will say here. See, though for 3 lambda by 2 we are getting a bright point, 5 lambda by 2 we are getting a bright point, but the intensity of the brightness will reduce, keep on reducing. The reason is that, see, in this case, which part of the slit is contributing for the bright point? This part, right? 1/3 of the slit. This part is nothing but 1/3 part of the slit, because we divided the slit into 3 parts. For this case, we are dividing the same slit into 5 parts. The first 4 part is not contributing to intensity, only the 5th part is contributing. That means there 1/5 of the slit is taking part in the formation of bright. So the width of the slit is reducing. Here it was 1/3, here it is 1/5, then 1/7. So in that way the part of the slit which is producing the bright point is reducing, and as a result the intensity of bright will also reduce. Okay, it is not like interference. In interference the intensity was same. That is the difference between diffraction and interference. In interference the brightness or the intensity of bright fringes remain uniform theoretically. Okay, but in diffraction it is not uniform, it reduces with the number. Okay, in next video we'll discuss about fringe width.